Well, hey there, kiddos. Unfortunately, I have a cold today, so my voice sounds a little bit deeper than normal. But we're going to be solving systems using elimination. Last week, we solved systems using substitution, and this time, instead of substituting an x or a y, we're going to be eliminating one of them to start with before we go back and solve it. So if I look at my steps here, it asks me to line up the x's, the y's, the equals, and the constants. Fortunately, in number 1 and number 2, our x's, our y's, and our constants are all nicely lined up. So number 3 is the big step that makes elimination work. We'd set up a fair fight to eliminate the variables. Now, a fair fight means they have to be equal and opposite on both sides. So if I look at number 1 here, I don't have to set up my fair fight because it's already done for me. I have my negative y and my positive y, which are already fair fighting, so they're going to cancel each other out. Just like in number 2, our x and our negative x will cancel each other out. So once our fair fight is set up, then we're going to add both of the equations together. After we do that, and we find our answer, it's going to be written as an ordered pair. Now, if we look at number 1 here, we've already said that the y's are going to cancel each other out because it's already a fair fight. So what I need to do is add these two equations together and see how my y's cancel out. So I see that 3x plus negative 2x is going to give me an x down here. And my negative y plus a positive y, we know those are going to cancel out now, so I'm just going to cross them out. And on the right side there, negative 2 plus 3 is going to give me 1. So nicely, everything kind of worked out, so I have my x right off the bat. I have x equals 1. Now for step 5, we're going to substitute it back into the problem. So I take this x equals 1, and I'm going to plug it back into either one of these equations. So I'll plug it back into the top part here, where I'll have 3 times 1 minus y gives me negative 2. Now we know that 3 times 1 is 3, minus y equals my negative 2. And we want to isolate the y to solve it. So I'll subtract 3 from both sides here, which will leave me with negative y equals negative 5, because we've taken 3 away from the negative 2. Then the last step is getting y by itself, so I'll divide by negative 1, and it gives me y equals 5. So I have my y and I have my x, but remember, we have to write them as an ordered pair. So my answer is going to be 1, 5. So there's your answer for number 1. Now we're going to skip past 2, and we're going to go down here to number 4. The first thing I want to see is make sure that everything is aligned. So I see that my x's, my y's, and my constants are all lined up. So the next step is going to be making a fair fight. I always want to pick the easiest variable to work with, and because that x has 3's and 2's in front of it, I really don't want to mess with it. But I do notice that the y's, there's only one of each of them. And the way to make a fair fight between a positive y and another positive y is just make one of them negative. So what we'll do is we'll take this bottom equation and we're going to multiply the entire bottom thing by a negative 1. Now whenever I do that, it's going to give me 3x plus y equals 5 on top, and then the bottom, since I multiply the whole thing by negative 1, gives me negative 2x minus y equals negative 10. Be sure that whenever you multiply it by a constant that every number gets multiplied. So now I can add them together. So whenever I add these equations together, 3x plus a negative 2x will give me an x, and now our plus y and our minus y are going to cancel each other out. And then 5 plus negative 10 gives me my negative 5. So there we go right off the bat again. I have my x solved for. So x equals negative 5. Now we're going to take that and we substitute it back in. So you can pick any of your equations to substitute it back into. So I'm just going to plug it back into the top one here. And I'll have 3 times negative 5 plus y equals 5. Whenever we solve that, I know that 3 times negative 5 is negative 15 plus y equals 5. In order to get the y by itself, I'm going to add 15 to both sides here. And boom, we've got y equals 20. So I have my x now and I have my y, and we always want to write them as an ordered pair. So I'll have negative 5, comma, 20 as my answer. Now we can always check these. After you get an answer, if you have extra time on a test or if you just want to see if you're right, we can take our ordered pair and we can plug it back into the equation that we just solved. So the ordered pair that we got there was negative 5, comma, 20. So if I plug those back into any equation, we'll use the first one for example. I'd have 3 times negative 5 plus 20, and if it's right, then it should equal 5. So if I have 3 times negative 5, that gives me negative 15 plus my 20. Well, negative 15 plus 20 equals 5, so I know that my answer is right for that one. So now we can move on to the next one. So if we look right below there, it says, how could you make it a fair fight between 2x and negative 4x? Well, we know that a fair fight means that they have to be able to cancel each other out, and 2x and negative 4x can't quite do it yet. But if we multiply this 2x by a positive 2, we'd have 2 times 2x, which would give you 4x, and then we notice that if we have negative 4x and 4x, they would cancel each other out. So your answer there would be multiply the 2x times 2. Now let's look at number 6. It's a little bit different because you notice that the x's and the y's aren't by themselves, so they're not going to cancel. So now we're going to have to multiply the top and the bottom equations by some constant to get them to cancel. Well, I'm always going to try to work with the smallest numbers here. And if I notice 3 and 2 are going to be a lot easier to cancel than 5 and 3. So if we're working with the x's here, 3x and 2x, I know that I can get to 6x pretty easily by multiplying the 3x times 2 and the 2x times 3. Now we need them to be 6 because they'll be able to cancel out at that point. So what I'm going to do is multiply the entire top equation by negative 2, and then I'm going to multiply the bottom equation by a positive 3. Now the reason I'm doing opposites is because one needs to be negative and one needs to be positive to cancel out. So if I rewrite the top equation now, I have negative 2 times 3x gives me negative 6x plus 10y, because a negative 2 times a negative 5 gives me a positive number, equals negative 68 out here. And as for the bottom equation, if I multiply the whole thing by 3, I'd have 3 times 2 gives me 6x minus 9y, because 3 times negative 3 is negative 9, equals a positive 66 down here. So now we can add both of our equations together. And we see that those x's right there, our negative 6x and our positive 6x, are in a fair fight, so they're going to cancel each other out. And with our y's, we have a 10y minus 9y gives us 1y left over, equals negative 68 plus a positive 66 is going to be a negative 2. So now I have y equals negative 2 there. Now I'm going to take that y equals negative 2 and again plug it back into the equation on anywhere that I see a y. So we'll use this one. And so that gives us 3 times x minus 5 times negative 2, because we just plugged in that y that we just found for our y right here, equals 34. Well, the 3x stays the same. A negative 5 times a negative 2 becomes a positive 10 equals 34. And now to find our x, we're going to subtract 10 from both sides. So 3x equals 24. And if we divide both of them by 3 now, we see that x equals 8. So I have my x and my y, except this time the question's not asking me for an ordered pair. It's saying x minus y. So I have my x right here and I have my y. Now if I do x minus y, I have 8 minus negative 2. Well, whenever you subtract a negative, the signs change and it becomes 10. So my answer for that one is going to be 10. So now let's look at the... We've got some word problems here. So the first one says, David and Jose went to Target to buy clothes. David bought 2 shirts and 1 pair of jeans for $53.50, and Jose bought 2 shirts and 3 pairs of jeans for $108.50. How much is 1 pair of jeans? Well, anytime that we have a word problem, the first thing we want to do is identify what we're actually looking for. So the question's asking us to find jeans, and in the problem, it tells us that they're buying shirts and jeans. So we're going to have 2 variables to start with here, and I'll set x equal to jeans, and then I'll set my y equal to shirts. So if we want to make our first statement, we're going to look at what David did. So David bought 2 shirts and 1 pair of jeans, and we know that our shirts is y and our jeans is x. So if he bought 2 shirts, it's going to be 2 times y and 1 pair of jeans, so plus 1 times x equals $53.50. Now let's go look at Jose. Jose bought 2 shirts and 3 pairs of jeans for $108.50. Well, 2 shirts would be 2 times y, and 3 pairs of jeans is going to be 3 times x equals my $108.50. So there are my 2 let statements right there. So go ahead and take a second, and we're going to write both of those statements in the box on the left for let statements. Now looking at my let statements, the easiest ones to set up a fair fight and cancel out are probably going to be our y's, because there's 2 of them in both equations, but they're both positive. So what we need to do is make one of the equations negative. So what we'll go ahead and do is multiply the entire bottom equation by a negative 1. So that gives me 2y plus x equals $53.50 in the top. And then in my bottom, if I multiply it all by negative 1, I'd have negative 2y minus 3x equals negative 108.50. Now when I add both of these together, I have my y's that cancel out now, and my x's, positive x minus 3x would be a negative 2x equals $53.50 plus a negative 108.50, which gives me negative $55. So if I divide both of those by negative 2, I end up with x equals $27.50. And we know that my x was jeans, so that's all I need to stop at right there. So I have my answer, $27.50 for jeans. And now the last one that we're going to do is number 8. So it says we've got each family in a neighborhood is contributing $20 worth of food to the neighborhood picnic. The Harlan family is bringing 12 packages of buns, and the hamburger buns cost $2 per package. The hot dog buns cost $1.50 per package. How many packages of each type did they buy? Again, the first thing you want to look at is what are our variables. Well, I can see that we've got hamburger buns and hot dog buns, so that's what we're going to make x and y. So we'll go ahead and call x hamburger buns, and we'll call y hot dog buns. And now these are going to be referring to the packages. So if we look back at the question, it says 12 packages of buns total. Well, if we know that x is packages of hamburger buns and y is packages of hot dog buns, and we have 12 total, our first equation there is going to be x plus y equals 12, because there's 12 packages total of each one. And now our second equation, we know that hot dog buns cost $1.50 and hamburger buns cost $2 per package. Well, hamburger buns are going to be our x, and if they're $2 each, we're going to have 2 times x, and our hot dog buns are $1.50 each per package, so we'll have 1.5 times y. And we're looking at money now, so $2 for each hamburger package and $1.50 for each hot dog package gives us $20 total, like they told us in the problem, so we'll have that equal to 20. Now if we want to set up a fair fight here, the easiest ones are going to be working with the x's, because y's has a decimal in it, and I really don't want to do decimals. So if we want to set it up as a fair fight, what I'll do is go ahead and multiply the top equation by negative 2. And what that'll do is make it so the hamburger buns cancel out. So if I do negative 2 times the top equation there, it gives me negative 2x minus 2y equals negative 24. And I will leave the bottom one just the way it is there. So that's 2x plus 1.5y equals 20. Well, when we add them together, my negative 2 and 2x are going to cancel out. My negative 2 and a positive 1.5 will leave me with a negative 0.5y equals negative 4, because negative 24 plus 20 gives me negative 4. Well, if I divide both of those numbers by a negative 0.5, that ends up giving me y equals 8. So we know I have 8 packs of hot dog buns, but we also need to know how many hamburger buns we have. Well, the easy part about this is that I can look over here at this nice easy x plus y equation, and I'll plug in y equals 8 over here. So x plus 8 would have to give me 12. So I know my x would have to be 4. So x equals 4. So we know that we have 4 packs of hamburger buns and 8 packs of hot dog buns. And that answers our question there. The only thing I forgot to do was write my let statements in that box. So we want to make sure that we take both of these statements right here, and that's what goes in this nice little small box right there. But that's all we've got for you, and that's solving systems with elimination. So we'll see you tomorrow. Y'all have a good rest of your day.